The next load we call the next load is the uplift force or seepage load. Okay, this one is a normal load, one type of normal load. Water enter the pore, fissure and cracks of the foundation material, and the joint between the dam and foundation. This water seeps through and try to emerge out of the downstream end. So seeping water creates a hydraulic gradient between upstream and downstream side of the dam, so causing the vertical uplift pressure or uplift force. Okay, for the uplift pressure at the heel, okay, equal to the unit weight of water gamma times the height of the stored water in the dam. So HU, so that is the gamma HU for uplift force at the heel. And uplift force at the downstream is equal to gamma HD. HD is the height of the water downstream of the dam. In this case, if there is no water, no height of water downstream, it can be 0. Okay. If there is no dynamic catalyst system and no water downstream, uplift pressure distribution is a straight line to 0. Okay, it's a straight line to 0. If the drainage catalyst exists and uplift force distribution is decreased, equal to 2/3 of the difference between the pressure at the upstream downstream. So this is the rain recovery, and so it's reduced to 2/3. So it still have the 1/3 for the gamma HU. And this shows how to reduce the uplift pressure. We can use the Gauss curtain to reduce the pressure distribution, and another way we use is like the gallery. Okay, we can cut down the pressure, uplift pressure. Okay. For the abnormal load, the first is come from the hydrodynamics force from the earthquake, pH. Okay. Horizontal earthquakes makes this factor. We can estimate F E is a force from the hydrodynamic pressure. This come from pressure times the H. And for the pressure is come from this function of the C, alpha and gamma H. H is the maximum depth of water. And for C is a function of theta. Okay, theta is the upstream angle with the vertical. So in this case, if the dam So in this case, the theta is equal to 90 degrees. Okay. In some case, it's like this. So in this case, theta is greater than 90 degrees. Okay. So if theta is like 90 degrees, the C is 0.73. And this is an equation for the moment at the heel. M is the moment at around the heel of the dam. Okay. And for the W is the unit weight of water, 1 ton per cubic meter. Next, abnormal load is the inertial force from the earthquake. Okay. Impact from the horizontal earthquake creates the acceleration alpha. So inertial force is equal to weight times alpha. And direction of the force is depend on the direction of the alpha. And normally it's opposite side of the direction between alpha and force. Impact from vertical earthquake create the initial force of concrete, water, and sediment. This force is increased if the vertical earthquake's acceleration is upward. Okay. Yes, and we multiply mass of the concrete, water, and sediment with this factor. If the alpha V is downward and multiple mass of concrete and water and sediment is a negative. Okay. So we can make a note that the direction of the initial force is opposite to the acceleration. Okay. In this case, if we draw the copy them like this. Okay, so we can write the weight of this cavity dam W1, W2. Okay, and hydrostatic force. In this case, if the acceleration is downward, like this for the acceleration, so for the initial force is opposite to the direction of acceleration, so we can write for PE. Oh. Okay, the direction of the initial force is opposite to acceleration. In this case, we want to subtract alpha V so because we want 1. Okay, so that is the meaning of this. Okay, 1 subtract alpha V if the direction of the vertical earthquake is downward. Okay. The next is the water waves. The pressure from the water wave is function of the unit weight of the water and the height of the wave. Okay, and the height of the wave is function of V and F. If the F is less than 32, in this for case F is greater than 32. So V is a wind velocity and F is a phase or direction direct distance of the wind flow in the meter of kilometer. And HW is the height of the wave. Okay, and the location of the wave force acting on the above water level in the dam is this 3 of 8 of HW. So we can draw like this. It is assumed this is the height of the wave. And this is the pressure from the wave. Okay, the acting force is about one straight that for of the 8 h time of HW. Okay.